November 7th, 1943. A grey morning over northern France. The sky hung low with clouds that looked like wet wool. At a small airfield near Caen, still under German occupation, the sound of a single American fighter engine cut through the mist. It wasn't the usual thunder of bombers passing overhead or the distant crackle of anti-aircraft fire. This was different, closer. Lieutenant William Roach of the 358th Fighter Squadron had been flying for less than 3 hours. It was his third combat mission, and already everything had gone sideways. Poor weather, radio interference, fuel gauges dropping faster than they should. When he spotted what he thought was an Allied airfield through a gap in the clouds, he didn't hesitate. His squadron leader had just crash-landed somewhere behind him. The fuel warning light had been glowing red for the past 10 minutes. He dropped the landing gear and brought the P-47 Thunderbolt down in a perfect approach. Wheels kissed the runway. The big radial engine roared as he reversed pitch on the propeller blades. Only when he rolled to a stop and saw the ground crew running toward him did he notice something that turned his blood to ice. They weren't wearing American uniforms. They were wearing field grey. The aircraft was surrounded within seconds. German soldiers, rifles raised, shouting in a language Roach barely understood. He raised his hands slowly, his mind still catching up to what had just happened. He had confused a French airfield with one in southern England. He had just delivered one of America's most powerful fighters directly into enemy hands. Intact, undamaged. With a full tank of oil and nearly 40 gallons of fuel still in the wings, the Germans stared at the machine with a mixture of disbelief and something close to hunger. One officer walked around the aircraft slowly, running his hand along the cowling, the oversized propeller, the wide landing gear. He whispered something to his men, and within minutes a tarp was thrown over the plane. Guards were posted. A radio call was made to Paris, then to Berlin. By nightfall, the order came through. The aircraft was to be transported immediately to Rechlin, the Luftwaffe's primary test and evaluation center north of Berlin. This was not just a captured enemy plane. This was intelligence in metal form. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The journey from Caen to Rechlin took more than a week. The P-47, coded YFU and nicknamed Beetle by its original crew, was carefully disassembled just enough to fit onto a flatbed railcar. Its wings were unbolted, the canopy removed, the guns stripped, but the engine, that massive 18-cylinder Pratt & Whitney R-2800 double wasp, remained untouched. The Germans wanted it whole. They wanted to understand it. At every stop along the rail line, soldiers guarded the cargo with the intensity usually reserved for gold or ammunition. Word had already spread through Luftwaffe intelligence channels. The Americans had a new fighter, bigger and heavier than anything the Reich had seen before. It could escort bombers deep into Germany and return home. It could absorb punishment that would shred a Messerschmitt. And somehow, despite weighing as much as a small truck, it could still fight at altitudes where German engines choked on thin air. When the train finally pulled into the rail yard near Rechlin on November 15th, the sky was already dark. Snow drifted across the tracks, settling on the tarp that covered the fuselage. A small convoy of trucks waited. By dawn, the P-47 had been reassembled inside Hangar 9, a building normally reserved for prototypes and experimental designs. Under the harsh glare of floodlights, the aircraft looked almost alien. Its skin was painted in olive, drab and neutral grey, scratched and dented, from months of combat missions. But beneath the wear, the structure was solid, uncompromising, built to last. Oberingenieur Franz Kessler stood at the nose of the aircraft, arms crossed, his breath visible in the cold air. He was one of Rechlin's senior engineers, a man who had spent the past decade designing and testing every major German fighter from the Bf 109 to the early prototypes of the jet-powered Me-262. He had seen the best that German engineering could produce. He had flown with aces. He had watched the Luftwaffe grow from a secret project into the most feared air force in Europe. But standing in front of this American machine, he felt something he hadn't expected. Doubt. Its radial engine alone looked larger than the entire power section of a Focke-Wulf 190. The propeller measured nearly 13 feet across, each blade as wide as a man's chest. The fuselage was thick, heavy, almost brutish in its proportions. Everything about it defied the principles of elegant design that German engineers held sacred. This was not a thoroughbred. It was a workhorse. Yet, the Americans were winning. Kessler turned to his team, a group of 6 engineers and mechanics who had been pulled from other projects for this analysis. They stood in a semicircle around the aircraft, notebooks open, measuring tools in hand. One of them, a young technician named Dietrich Halder, was already running his fingers along the engine, cowling, tracing the seams where panels met. "It's so clean," Halder murmured. "No rivets standing proud, no gaps, everything flush." Kessler nodded. He had noticed the same thing. German aircraft were built with precision, but they still showed their construction. Rivets, panel lines, access hatches, all visible, functional, but not invisible. This American plane looked almost molded from a single piece of metal. The skin was smooth, polished, optimized for airflow. It was a level of finish that required either extraordinary craftsmanship or extraordinary machinery. "Let's start with the basics," Kessler said. "Dimensions, weight, control surfaces. I want every measurement cross-referenced with our own fighters. Then we open the engine." The team moved into action. They measured the wingspan. 40 feet, 9 inches. Longer than a Bf-109 by nearly 8 feet. They weighed the aircraft using a portable scale brought in from the experimental shop. 10,200 pounds empty. Fully loaded, it would weigh more than 17,000 pounds. That was nearly double the weight of a Focke-Wulf 190A. One engineer, a former Luftwaffe pilot named Werner Vogel, shook his head in disbelief. "How does this thing even take off?" Kessler didn't answer immediately. He was staring at the engine, at the massive bulk of it nestled inside the cowling. The answer was obvious. Power. Raw, uncompromising, American power. Over the next 2 days, the team carefully removed the cowling panels. Each piece came off with surprising ease. The Americans had designed the engine to be serviced quickly, with large access doors and simple fasteners. German engines required hours of disassembly just to reach the spark plugs. This one could be inspected in minutes. When the cowling finally came away, the R-2800 was revealed in full. It looked like something forged by gods of industry. 18 cylinders arranged in 2 rows, each one perfectly machined, perfectly aligned. The cooling fins were cut so precisely they looked like the teeth of a comb. The exhaust manifolds were heavy, reinforced, routed through a maze of ducting that led to a massive turbocharger mounted at the rear of the engine. Halder leaned in close, his flashlight beam playing across the metal. "Look at the finish. Every surface is polished. No tool marks, no casting imperfections." He ran his hand across one of the cylinders, feeling the smoothness of the alloy. It was cold to the touch, but it carried a kind of weight beyond its physical mass. This was not just a component. It was a statement. "Start taking measurements," he said quietly. "Bore, stroke, displacement. I want to know everything." The team worked methodically. They measured the bore at 5.75 inches, the stroke at 6 inches. They calculated the displacement at 2,804 cubic inches, or 46 litres. It was the largest production radial engine any of them had ever seen. The WWII that powered the Focke-Wulf 190 displaced just under 42 litres and produced roughly 1,800 horsepower. This American engine was rated at over 2,000 horsepower. Some intelligence reports suggested it could push as high as 2,800 with water injection. Kessler stared at the numbers in his notebook. The math was simple but devastating. The Americans had built an engine that produced more power per litre than anything in the German arsenal, and they were building them by the thousands. Werner Vogel, the former pilot, spoke up from the other side of the engine. "Franz, you need to see this." Kessler walked around the massive power plant. Vogel was pointing at the rear section, where a large cylindrical housing sat bolted to the engine block. It was connected to the exhaust manifolds by a series of heavy steel pipes, each one wrapped in insulation. "Turbocharger," Vogel said. "But not like ours. This is huge." Kessler had seen turbochargers before. The Luftwaffe had experimented with them on high-altitude bombers and a few prototype fighters. But those systems were delicate, temperamental, prone to failure. They required exotic alloys that Germany no longer had in sufficient quantity. Nickel, chromium, cobalt. All of them rationed, all of them scarce. Yet here was an American turbocharger, built into a production fighter, operating as standard equipment. He ran his hand along the housing, feeling the weight of it. The metal was dense, heat-resistant, probably some advanced alloy that could withstand temperatures above 700 degrees Celsius. "They're not just using it for emergencies," Kessler said. "This is how the engine operates normally. At altitude, the turbo keeps feeding compressed air into the cylinders. It's why they can fly so high." The implications hit him like a physical blow. The Luftwaffe's fighters were designed to dominate at low and medium altitudes. The WWII performed beautifully below 20,000 feet, but above that, performance dropped off sharply. The air was too thin. The supercharger couldn't keep up. The Americans had solved that problem with brute force and advanced metallurgy. Their P-47 seconds could cruise at 30,000 feet, fully powered, fully combat-ready. They could dive from above, attack, and climb back out of reach before a German fighter could react. It wasn't tactics, it wasn't pilot skill. It was engineering. Halder spoke from his position near the front of the engine. Halder had removed one of the cylinder heads, exposing the valve assembly underneath. The machining was extraordinary. Each thread was cut with microscopic precision. The valve seats were perfectly concentric. The springs were uniform, tensioned identically. It was the kind of work that would take a German craftsman hours. Yet this had come off an assembly line. "Look at the tolerances," Halder said. "I measured them. Less than 5/1000ths of an inch deviation across all 18 cylinders. That's impossible." "Not impossible," Kessler said quietly. "Just not possible here." The room fell silent. Everyone understood what he meant. Germany's aircraft engines were built by skilled workers in factories that had been bombed repeatedly. Parts were hand-fitted, adjusted, tuned. Each engine was unique, a product of individual craftsmanship. It was beautiful. It was artisanal. It was slow. The Americans had industrialized perfection. Their engines were not crafted. They were replicated. Every R-2800 that rolled off the production line in Connecticut or Michigan was identical to the last. Interchangeable parts, standardized tolerances, mass production refined to an art form. Kessler walked to the edge of the hangar and stared out at the snow-covered airfield. In the distance, he could see the skeletal frames of German fighters under construction. Each one took weeks to build. Each engine required hundreds of hours of assembly and testing, and even when they were finished, they could only fly for so long before needing major overhauls. The Americans were building P-47 seconds faster than the Luftwaffe could shoot them down. And every one of them carried an engine like the one sitting in Hangar 9. An engine that didn't just work, an engine that endured. He turned back to his team. "Continue the analysis. I want every component, catalogued. Metallurgy samples, stress tests, everything." They could measure every bolt, analyze every alloy, document every design choice, but they could never replicate it, not at scale, not with the resources Germany had left. The R-2800 wasn't just an engine, it was the product of an industrial system that Germany could no longer compete with. It was the embodiment of American abundance, forged in factories that ran day and night without fear of bombing, fueled by supply chains that stretched across oceans. That night, Kessler wrote the first page of his report. The words came slowly, each one heavier than the last. The American Pratt & Whitney R-2800 represents a paradigm shift in aircraft engine design. It is not remarkable for any single innovation, but for the totality of its execution. Power, reliability, and manufacturability have been integrated into a system that operates beyond the current capabilities of the Reich's industrial base. He paused, pen hovering over the paper. If this engine is standard equipment for their fighters, we must assume they possess the means to produce them in unlimited quantities. This is not a weapon. This is a strategy. Outside, the wind howled across the frozen airfield. Inside Hangar 9, the R-2800 sat silent, its 18 cylinders gleaming under the lights like the heart of a sleeping giant. Part 2. The winter of 1943 was brutal across northern Germany. Snow fell in sheets, covering the runways at Rechlin until they looked like endless white fields. Inside Hangar 9, the temperature barely rose above freezing despite the coal-burning stoves that hissed and sputtered in the corners. The engineers wore heavy coats over their uniforms, their breath visible as they worked. Franz Kessler had barely slept in 3 days. The examination of the R-2800 had consumed him in a way nothing else had during the war. Every measurement, every test, every component told the same story. The Americans were not just ahead, they were operating in a different dimension of industrial capability. On the morning of November 20th, test pilot Hans-Werner Lersch arrived at Rechlin. He was young, barely 30, but already legendary within the Luftwaffe's test community. He had flown over 100 different aircraft types, from captured Spitfires to experimental German jets. His logbook read like a museum catalogue of aviation history. Kessler met him at the hangar entrance. "Hans, thank you for coming." Lersch nodded, his eyes already moving past Kessler to the P-47 sitting under the lights. "So this is the Thunderbolt. I've heard stories. All of them are probably true." They walked together toward the aircraft. Lersch circled it slowly, taking in the proportions, the bulk, the aggressive stance created by its wide landing gear and tail-sitting attitude. He ran his hand along the fuselage, tapped the skin, tested the control surfaces. He said, "Like a tank. It weighs as much as one." Lersch smiled faintly. "And yet, it flies. That's the mystery, isn't it?" Kessler gestured toward the exposed engine. "The mystery is in there. We've been studying it for days. Every time we think we understand it, we find another layer." Over the next hour, Kessler walked Lersch through their findings. The massive displacement, the turbocharger system, the precision manufacturing, the redundant ignition, the oil cooling system that could operate for hours at full power without overheating. Lersch listened in silence, occasionally asking questions, but mostly just absorbing the information. When Kessler finished, the test pilot stood for a long moment, staring at the engine. "Have you weighed the cylinders?" he asked finally. "Yes. Each one is roughly twice the weight of a comparable BMW cylinder. And the quality? Flawless. Not a single casting, defect. Not a single imperfection in the machining." Lersch nodded slowly. "They're building these for endurance. Not for sprint performance, but for marathon capability." "Exactly. Which means they expect the war to last long enough that endurance matters more than peak power." Kessler hadn't thought of it that way, but Lersch was right. The R-2800 was designed with the assumption that aircraft would fly hundreds of missions. German engines were designed with the assumption that the war would be over quickly, that peak performance mattered more than longevity. That assumption had been wrong. 2 days later, the engine was moved to a test stand in a separate building. The team had spent hours connecting fuel lines, oil lines, ignition leads, and instrumentation. The turbocharger's exhaust ducting was routed to the outside through a specially constructed port in the wall. Every sensor they could attach was attached. Thermocouples, pressure gauges, tachometers, fuel flow meters. The goal was simple: run the engine at various power settings and record everything. When the moment came, Kessler stood at the control panel, while Halder and Vogel monitored the instrumentation. Lersch watched from the observation window, arms crossed, his expression unreadable. Kessler engaged the fuel pump, checked the oil pressure, set the mixture. Then he pressed the starter. The engine turned over once, twice. On the third rotation, it caught with a deep, resonant bark that shook the walls. Black smoke poured from the exhaust stacks as the cylinders cleared. Then the smoke thinned, and the sound settled into a steady, confident rumble. Kessler advanced the throttle slowly. The tachometer needle climbed. 1,000 revolutions per minute, 1,500. 2,000. The sound grew from a rumble to a roar, filling the test cell with a thunder that seemed to compress the air itself. At 2,500 revolutions per minute, with the manifold pressure at 52 inches, the engine was producing close to 2,000 horsepower. The entire test stand vibrated. The fuel flow was enormous, gallons per minute pouring through the carburetors. Yet the engine ran smoothly, its 18 cylinders firing in perfect synchronization. Holder shouted over the noise. Oil temperature stable at 90 degrees Celsius, cylinder head temperatures all within normal range. Kessler reduced the throttle slightly, then activated the turbocharger's wastegate control. The boost pressure climbed. The manifold pressure needle swung past 55 inches. 60. The sound changed pitch, becoming sharper, more urgent. 70 inches manifold pressure, Vogel called out. 2,400 horsepower. And still, the engine ran. No overheating, no detonation, no mechanical stress audible above the roar. It was producing more power than any German engine in service, and it was doing so as if it were routine. After 15 minutes, Kessler brought the power back to idle. The roar subsided to a confident growl. He let it run for another 5 minutes at low power, then shut it down. Lersch entered the test cell, his face grim. That, he said quietly, is what we're up against. Kessler nodded. He walked to the engine, placed his hand on one of the cylinder heads. It was hot, but not dangerously so. The cooling fins had done their job perfectly. The oil system had maintained temperature. Everything had worked exactly as designed. It's not just that it makes power, Kessler said. It's that it makes power reliably, over and over, without failure. How many of these do they have? Lersch asked. Kessler pulled a folded intelligence report from his pocket. According to our sources, Pratt & Whitney is producing approximately 500 R-2800 engines per month. That's just one factory. Ford is building them under license. So is Chevrolet. Lersch's expression didn't change, but Kessler saw his jaw tighten. 500 engines per month. That was more than the entire German aviation industry produced across all engine types combined. And the Americans were using those engines not just in fighters, but in bombers, transport aircraft, even naval patrol planes. What about materials? Lersch asked. The turbocharger housing, the exhaust manifolds, those require nickel alloys. We took samples, Kessler said, sent them to the metallurgy lab in Berlin. The turbine blades are made from an alloy called Inconel, 20% nickel, 14% chromium, with traces of cobalt and molybdenum. It can withstand temperatures above 800 degrees without deformation. And we don't have enough nickel to build 10 of those turbines, let alone thousands. Correct. Lersch turned away, staring at the engine through the observation window. Even if we copied this design exactly, we couldn't build it. We don't have the materials. We don't have the machine tools capable of that level of precision. We don't have the time. Kessler said nothing. There was nothing to say. Lersch was stating facts, not opinions. Over the following weeks, the examination continued. They disassembled the valve train, studying the spring rates and cam profiles. They measured the propeller reduction gearing, marveling at the precision of the teeth. They examined the magnetos, the fuel injection system, the automatic boost control. Every component was engineered not just for performance, but for reliability and ease of manufacture. One discovery particularly struck the team: the spark plugs. American spark plugs were standardized across multiple engine types. The threads, the heat range, the electrode gap, all designed to a common specification. A mechanic in England could replace a spark plug on a P-47 using the same part from a B-17 bomber. It was interchangeability taken to its logical extreme. German spark plugs, by contrast, were often unique to each engine type. The BMW 801 used different plugs than the Daimler-Benz 605. Even within the same engine family, different variants required different parts. It was precision craftsmanship, but it was also logistical chaos. The Americans had sacrificed uniqueness for universality, and in doing so, they had created a system that could scale infinitely. In early December, Kessler compiled his findings into a comprehensive report. It ran to 47 pages, filled with measurements, photographs, metallurgical analyses, and performance data. But the conclusion was just 3 paragraphs long. The Pratt & Whitney R-2800 double wasp represents not merely an advancement in engine technology, but a fundamental reimagining of how military power plants should be designed and manufactured. Its strength lies not in revolutionary innovation, but in the systematic optimization of known principles combined with industrial production methods beyond the current reach of the Reich. The engine's performance, characteristics, particularly at high altitude, give American fighters a decisive advantage in the European theater. More significantly, the scale of production and the standardization of components suggest that the United States possesses the industrial capacity to sustain air operations indefinitely. Recommendation: while technical study should continue, primary focus must shift to developing countermeasures rather than attempting replication. The material and industrial prerequisites for producing comparable engines in meaningful quantities do not exist within current German capabilities. He signed the report, placed it in a sealed envelope, and sent it to Berlin via military courier. He knew it would be read by senior officers, perhaps even by Reich Marshal Göring himself. He also knew it would change nothing. The factories would continue building BMW 801s and Daimler-Benz 605s. Skilled workers would continue hand-fitting pistons and tuning carburetors. The Luftwaffe would continue fighting with the tools it had, because those were the only tools it could make. That evening, Kessler stood outside Hangar 9, smoking a cigarette in the cold December air. Lersch found him there, collar turned up against the wind. "I flew it today," Lersch said. Kessler turned. "The P-47? They repaired the hydraulics and fueled it up. I took it up for 30 minutes. And?" Lersch was quiet for a moment. When he spoke, his voice was soft. "It's heavy. At low altitude, it feels sluggish. But above 5,000 meters, it transforms. The engine doesn't lose power. If anything, it seems to get stronger. The turbocharger keeps feeding it air, and it just climbs. And climbs. I took it to 9,000 meters. Still had power to spare." He paused, then added, "Our fighters can't do that. Not with full fuel. Not with ammunition. The Americans can fly over us, attack when they want, and break off when they want. We're fighting a war where they control the altitude. That means they control everything." Kessler took a drag from his cigarette. "Did you write a flight report?" "Yes. I was honest in it. I said, the Thunderbolt is not a dogfighter. It's too big, too heavy for close-in maneuvering. But as an interceptor at high altitude, and as a fighter bomber, it's devastating. And the engine, that R-2800, it's the reason why. They'll want your report. They'll get it. But Franz, the people in Berlin don't want to hear that we're overmatched. They want to hear that we're still the best. That German engineering is superior." "Is it?" Lersch looked at him. "Once, maybe. But not anymore. Not when superiority is measured in numbers." If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The winter deepened. Allied bombing raids continued to pound German cities and factories. By January 1944, the P-47 inches Hangar 9 had been stripped to its frame, every component catalogued, every measurement recorded. The R-2800 engine had been disassembled completely, its 18 cylinders laid out on workbenches like the organs of some mechanical giant. Engineers from other facilities came to see it, professors from technical universities, representatives from BMW and Daimler-Benz. They walked around the pieces, asked questions, took notes. They all reached the same conclusion. The engine was a masterpiece of industrial design, but it was not a masterpiece that could be reproduced in Germany. The materials didn't exist in sufficient quantity. The machine tools that could achieve those tolerances were either destroyed by bombing or had never been built in the first place. And even if both problems were solved, there was no time. The war was moving too fast. One cold morning in late January, Kessler received orders to pack up the analysis and prepare the P-47 for transfer to Circus Rosarius, a special Luftwaffe unit that travelled to frontline fighter groups to familiarize pilots with enemy aircraft. The Thunderbolt would be painted with German markings and demonstrated so that pilots would know what to expect when they encountered it in combat. It felt like a small consolation, a way of turning intelligence into tactics. But Kessler knew the truth. No amount of tactical knowledge would overcome the fundamental imbalance in resources. Before the P-47 was taken away, he walked through the hangar one last time. The reassembled aircraft sat under the lights, its olive-drab paint now marked with German crosses and a yellow-painted tail. It looked strange wearing those markings, like a wolf dressed in sheep's clothing. He placed his hand on the cowling, feeling the cold metal under his palm. Somewhere in Connecticut, in a factory that ran 3 shifts a day, another R-2800 was rolling off the assembly line, and another, each one identical, each one perfect, each one adding to a fleet that Germany could never match. "Goodbye, American," he whispered to the machine. "You've taught me more than I wanted to know." The Luftwaffe continued to fight through 1944. German pilots adapted their tactics, learning to avoid altitude disadvantages, attacking only when circumstances favoured them. Some of them became aces, scoring impressive victories against overwhelming odds. But the mathematics were inexorable. For every P-47 shot down, 2 more arrived to replace it. The engine that powered them, that massive R-2800, proved nearly indestructible. Pilots reported hitting Thunderbolts with cannon shells that would have obliterated a Bf-109, only to watch the American plane continue flying. The engine took the punishment, kept running, and brought its pilot home. By the summer of 1944, the 9th Air Force's P-47 groups were flying ground attack missions across France. They destroyed trains, bridges, convoys, and airfields. The sound of their engines became synonymous with defeat. German soldiers called them Jabos, short for Jagdbomber, fighter bombers. They learned to dive for cover at the first sound of that deep, unmistakable roar. The BMW 801, Germany's best radial engine, continued to power the Focke-Wulf 190. It was a good engine, elegant and efficient, but it required constant maintenance. Overhauls every 50 flight hours, careful monitoring of temperatures and pressures. It was a thoroughbred that needed a skilled handler. The R-2800 was a draft horse. It didn't need care. It needed fuel, feed it gasoline and oil, and it would run for 200 hours before requiring major service. It forgave mistakes, it tolerated abuse, it worked. That was the difference. That was what Franz Kessler had understood standing in Hangar 9 during that frozen December. The Americans hadn't built a better engine through some leap of genius. They had built a more practical engine through systematic engineering, and then manufactured it at a scale that turned practicality into dominance. Kessler survived the war. He was captured by American forces in April 1945 and spent months in a prisoner of war camp near Frankfurt. During his interrogation, the American engineers asked him detailed questions about German aircraft and engines. He answered honestly. There was no reason to lie anymore. One of the American officers, a captain from Wright Field in Ohio, asked him about the captured P-47. "We heard you tested one at Rechlin. What did you think?" Kessler considered the question. Then he said, "I thought it was the most honest machine I had ever seen." The captain raised an eyebrow. Honest? It didn't pretend to be elegant. It didn't try to be beautiful. It was designed to do a job, and to keep doing that job, no matter what. That honesty is why you won. After his release, Kessler returned to what was left of Germany. The factories where he had worked were rubble. The test centers were destroyed. Rechlin itself had been bombed into oblivion in the final weeks of the war. The hangar where he had studied the R-2800 no longer existed, but the engine did. Thousands of them, still flying, still powering aircraft in air forces around the world. They flew for the French, the Brazilians, the Chinese. They powered airliners and cargo planes. Some were still in service in the 1960s, more than 20 years after the war ended. In 1952, Kessler was invited to attend an air show in Munich. It was a cold day, and the crowd was large. Among the aircraft on display was a restored P-47 Thunderbolt, painted in American wartime markings. When the engine started, that old familiar sound rolled across the airfield, deep, confident, unmistakable. Kessler watched as it taxied and took off, climbing into the grey German sky. The sound faded slowly, and he realized his eyes were wet. Not from sadness exactly, from understanding. He had spent his career trying to make engines that pushed the boundaries of performance. The Americans had made engines that pushed the boundaries of endurance. One approach produced marvels, the other produced victory. In his later years, Kessler wrote occasional articles for aviation magazines. He never spoke publicly about his time studying the R-2800, but once, in a private letter to a former colleague, he wrote a single paragraph that captured everything he had learned. "We believed that excellence meant perfection in every detail. The Americans believed that excellence meant reliability at any scale. We crafted instruments. They manufactured certainty. In the end, the side that could produce dependable power in unlimited quantities defeated the side that produced perfect power in limited numbers. That is not an engineering lesson. That is a philosophical one." Hans-Werner Lersche continued flying after the war. He became a commercial pilot, then an aviation consultant. He wrote a memoir about his experiences, testing captured Allied aircraft, including the P-47. In it, he described the Thunderbolt as excellent in higher altitudes, in diving attacks, and flying at maximum boost. But the line that stood out to Kessler, when he read the book years later, was simpler. The P-47 was heavy and difficult at low altitude, but at height it was in its element. Like the country that built it did not rely on elegance. It relied on power. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The R-2800 double Wasp engine became one of the most produced aircraft engines in history. By the time production ended in 1960, more than 125,000 units had been built. They powered not just P-47 Thunderbolts, but Corsairs, Hellcats, B-26 Marauders, C-46 Commandos, and dozens of other types. In Germany, the BMW 801 totaled just over 61,000 units across its entire production run. It was an impressive figure for a nation under siege, but impressive isn't the same as sufficient. The engineers at Rechlin understood this in 1943. By the time they disassembled that first captured P-47, they already knew how the war would end, not because they lacked courage or skill, not because their designs were inferior in principle, but because they were fighting an industrial system that operated on a different scale of reality. The R-2800 wasn't just an engine. It was evidence. Evidence that the outcome of the war had been determined not by tactics or bravery, but by factories, supply chains, and resources. Evidence that the side which could turn steel into certainty faster than its enemy could turn it into perfection would prevail. Franz Kessler died in 1973. He was buried in a small cemetery outside Stuttgart. At his funeral, a former Rechlin colleague mentioned the American engine. He said Kessler had once told him that understanding the R-2800 was like understanding the difference between art and industry. Art, Kessler had said, requires the right tools, the right materials, and the right moment. Industry only requires the right process. Art creates masterpieces. Industry creates inevitability. The colleague paused, then added, Franz always said we built masterpieces. The Americans built inevitability. That's why their engines are still flying. Somewhere in the sky above them, the distant sound of a radial engine passed overhead. Deep, steady, enduring. The sound of certainty. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.